Where are the aliens? What is the Fermi Paradox?
Section 51.
Section 51.
Section 51.
Hi everyone, what's up? I am GH aka DOZgeek. It's nice to be back here with you on Section 51. And thank you for your kind words in the chat every time we publish a new video here on Section 51. Excuse me, but very quickly I have a few words for our French viewers. Donc un petit coucou aux viewers francophones. Alors on nous a posé plusieurs fois cette question, pourquoi poster des vidéos en anglais et pas en français? Eh bien tout simplement parce que la communauté qui suit historiquement la chaîne Section 51 depuis ses débuts en 2014 est très majoritairement américaine et anglophone, et c'est aussi pour les remercier que les vidéos sur Section 51 resteront en anglais pour l'instant. Je sais qu'on aborde ici des sujets qui vous intéressent et c'est pour ça que je tiens quand même à souligner qu'on travaille beaucoup sur cette chaîne pour que vous ayez les sous-titres disponibles systématiquement sur chaque nouvelle vidéo. Comme ça, vous pourrez activer la traduction automatique de Google pour avoir les sous-titres en français. Et je dois dire que ça fonctionne plutôt pas mal. Alors il peut y avoir quelques bugs dans la traduction, mais bon, dans l'ensemble, c'est mieux que rien, non? Donc, vous voyez, on pense quand même aux petits Frenchies. Voilà. On se serre les coudes entre Français. Évidemment, le problème ne se posait pas quand on montrait juste des vidéos d'OVNI, mais on ne pouvait pas fonctionner comme ça indéfiniment. En tous les cas, il faut assumer ses choix. Alors désolé pour ce petit inconfort, ce petit désagrément, ce petit souci technique, et merci en tout cas à vous de suivre quand même la chaîne. Mais globalement, on ne s'interdit pas la possibilité de faire un jour peut-être quelques vidéos en français, qui sait, peut-être même sur un live, on verra s'il y a une forte demande. So also big thanks to our French viewers who have to watch the videos in English with the subtitles. I just wanted to say that we had to make a choice on the language before launching this new format of video. It was important that our videos could be understood worldwide by the majority of our viewers. The issues that we are talking about here are very interesting. They are so completely out of our cognizance that we can't limit to a single country. So why are we here now? Have you ever heard of Fermi's Paradox? What? But what the hell is he talking about again? Okay, relax, don't panic, we are getting there. It won't hurt too much. In fact, the Fermi Paradox seeks to answer the question of where the aliens are. Given that our star and Earth are part of a young planetary system compared to the rest of the universe, and that interstellar travel might be fairly easy to achieve, the theory says that Earth should have been visited by aliens already. As the story goes, Italian physicist Enrico Fermi, most famous for creating the first nuclear reactor, came up with the theory with a casual lunchtime remark in 1950. The implications, however, have had extraterrestrial researchers scratching their heads in the decades since. In 1950, while working at Los Alamos National Laboratory, Fermi had a casual conversation while walking to lunch with colleagues Emil Konopinski, Edward Teller and Herbert York. The men discussed a recent spate of UFO reports and an Alan Dunn cartoon facetiously blaming the disappearance of municipal trash cans on marauding aliens. The conversation shifted to other subjects until during lunch Fermi suddenly exclaimed, "Where are they?" Or rather, as interpreted, "Where is everybody?" The result of his question was general laughter because of the strange fact that in spite of Fermi's question coming from the clear blue, everybody around the table seemed to understand at once that he was talking about extraterrestrial life. Herbert York recalls that Fermi followed up on his comment with a series of calculations on the probability of Earth-like planets, the probability of life, the likely rise and duration of high technology, and concluded that we ought to have been visited long ago and many times over. Although Fermi's name is most commonly associated with the paradox, he was not the first to ask the question. An earlier implicit mention was by Konstantin Tsiolkovsky, a Russian and Soviet rocket scientist, in an unpublished manuscript from 1933. He noted,
"People deny the presence of intelligent beings on the planets of the universe because if such beings exist, they would have visited Earth. And if such civilizations existed, then they would have given us some sign of their existence."
This was not a paradox for others who took this to imply the absence of ETs, but it was for him, since he himself was a strong believer in extraterrestrial life and the possibility of space travel. Therefore, he proposed what is now known as the Zoo hypothesis and speculated that mankind is not yet ready for higher beings to contact us. The Zoo hypothesis is that alien life intentionally avoids communication with Earth, and one of its main interpretations is that it does so to allow for natural evolution and socio-cultural development, avoiding interplanetary contamination, similarly to people observing animals at a zoo. The hypothesis seeks to explain the apparent absence of extraterrestrial life despite its generally accepted plausibility and hence the reasonable expectation of its existence. But Tsiolkovsky himself may not have been the first to discover the paradox. It is suggested by his above-mentioned reference to other people's reasons for denying the existence of extraterrestrial civilizations. For example, Michael H. Hart published in 1975 a detailed examination of the paradox, which has since become a theoretical reference point for much of the research into what is now sometimes known as the Fermi-Hart paradox. Geoffrey A. Landis, an American scientist working for NASA, prefers that name on the grounds that while Fermi is credited with first asking the question, Hart was the first to do a rigorous analysis showing that the problem is not trivial and also the first to publish his results. Some other scientists prefer to use the term Hart-Tipler argument, acknowledging Michael Hart as its originator but also the substantial contribution of Frank J. Tipler in extending Hart's arguments. Other names closely related to Fermi's question, "Where are they?" include the Great Silence and Silentium Universi, from Latin for silence of the universe, though these only refer to one portion of the Fermi paradox, that we see no evidence of other civilizations. But let's get back to Enrico Fermi. He realized that any civilization with a modest amount of rocket technology and an immodest amount of imperial incentive could rapidly colonize the entire galaxy. Indeed, the Search for Extraterrestrial Intelligence Institute, SETI, in Mountain View, California, said on its website that within 10 million years, every star system could be brought under the wing of Empire. 10 million years may sound long, but in fact it's quite short compared with the age of the galaxy, which is roughly 10,000 million years. Colonization of the Milky Way should be a quick exercise. While Michael Hart was more of the opinion that we were the only advanced civilization in the galaxy, he argued that in Earth's history somebody could have visited us already unless They started their journey less than 2 million years ago. He outlined 4 arguments exploring the paradox. 1. Aliens never came because of a physical difficulty that makes space travel infeasible, which could be related to astronomy, biology, or engineering. 2. Aliens choose never to come to Earth. 3. Advanced civilizations arose too recently for aliens to reach us. And 4. Aliens have visited Earth in the past, but we have not observed them. The argument has been challenged on many grounds. Maybe star travel is not feasible, or maybe nobody chooses to colonize the galaxy. Or maybe we were visited long ago and the evidence is buried with the dinosaurs. But a Fermi Paradox researcher, Robert H. Gray, wrote in 2016 that the idea has become entrenched in thinking about alien civilizations. Frank Tipler, a professor of physics at Tulane University, do you remember him? Frank Tipler. We talked about him earlier. Tipler was followed up on the argument in 1980 with a paper titled Extraterrestrial Intelligent Beings Do Not Exist. The bulk of his paper dealt with how to get resources for interstellar travel, which he suggested could be achieved by having some kind of self-replicating artificial intelligence moving from star system to star system and create copies using materials there. Since these beings aren't on Earth, Tipler argued we are likely the only intelligence out there. He also said that those who believe in extraterrestrial intelligence are similar to those who think about UFOs, because both camps believe that we are going to be saved from ourselves by some miraculous interstellar intervention. And I'd like to say to this, why not? Today, the topic of extraterrestrial intelligence is a popular one, with several papers appearing every year from different researchers. It's also been fueled by the discovery of exoplanets. The universe is incredibly vast and old. One estimate says the universe spans 92 billion light-years in diameter, while growing faster and faster. Separate measurements indicate it is about 13.82 billion years old. At first blush, this would give alien civilizations plenty of time to propagate, but then they would have a cosmic distance barrier to cross before getting too far into space. Fermi first formed his theory long before scientists found planets outside of our solar system. There are now more than 3,000 confirmed planets, with more being found frequently. The sheer number of planets that we have found outside of our solar system indicates that life could be plentiful. Over time, with more advanced telescopes, scientists will be able to probe the chemical compositions of their atmospheres. The eventual goal is to understand how often rocky planets form in the habitable regions of their stars, which is traditionally defined as the zone in which water can exist on the surface. Habitability, however, isn't just about water. Other factors must be considered, such as how active the star is and what is the composition of the planet's atmosphere. A November 2013 study using data from the Kepler Space Telescope suggested that 1 in 5 Sun-like stars has an Earth-sized planet orbiting in the habitable region of its star. That zone is not necessarily an indication of life, as other factors, such as the planet's atmosphere, come into play. Further, life could encompass anything from bacteria to starship-sailing extraterrestrials. A few months later, Kepler scientists released a planet bonanza of 715 newly discovered worlds, pioneering a new technique called verification by multiplicity. The theory essentially postulates that a star that appears to have multiple objects crossing its face or tugging at it would have planets, as opposed to stars. In 2014, NASA said that using this will accelerate the pace of exoplanet discovery. Researchers previously focused on red dwarf stars as a possible host for habitable planets, but as the years of study continued, limitations arose. It was exciting to find nearby planets such as Proxima Centauri b and the 7 rocky planets of TRAPPIST-1 in the regions of their stars where liquid water could exist on the planet's surface. The trouble is, red dwarfs are volatile and could send several forms of life-killing radiation towards the surface. More study is required to better understand these stars. For example, the Transiting Exoplanet Survey satellite, TESS, launched successfully in April 2018 to study nearby stars. NASA's James Webb Space Telescope, expected to launch in 2020, will examine planets for the chemical makeup of their atmospheres. And the European Space Agency's Plateau for planetary transits and oscillations of stars is expected to launch in 2026. Our understanding of astrobiology, that is life in the universe, is just at the beginning, however. One challenge is these exoplanets are so far away that it is next to impossible for us to send a probe out to look at them. Another obstacle is even within our own solar system, we haven't eliminated all the possible locations for life. We know from looking at Earth that microbes can survive in extreme temperatures and environments, giving rise to theories that we could find microbe-like life on Mars, the icy Jovian moon Europa, or perhaps Saturn's Enceladus or Titan. All of this together means that even within our own Milky Way galaxy, the equivalent of the cosmic neighborhood, there should be many Earth-sized planets in habitable zones that could host life. But what are the odds of these worlds having starfarers in their bounds? The odds of intelligent life are estimated in the Drake equation, which seeks to figure out the number of civilizations in the Milky Way that seek to communicate with each other. First proposed by radio astronomer Frank Drake in 1961, the equation calculates the number of communicating civilizations by multiplying several variables. It's usually written according to the search for extraterrestrial intelligence SETI, like this: n equals r star times f sub p times n sub e times f sub e times f sub I times f sub c times L, where n is the number of civilizations in the Milky Way galaxy whose electromagnetic emissions are detectable. R star equals the rate of formation of stars suitable for the development of intelligent life. F sub p is the fraction of those stars with planetary systems. N sub e is the number of planets per solar system with an environment suitable for life. F sub e is the fraction of suitable planets on which life actually appears. And F sub I is the fraction of life-bearing planets on which intelligent life emerges. F sub c is the fraction of civilizations that develop a technology that releases detectable signs of their existence into space. And finally, L is the length of time such civilizations release detectable signals into space. None of these values are known with any certainty right now, which makes predictions difficult for astrobiologists and extraterrestrial communicators alike. While SETI's Frank Drake and others suggested there could be 10,000 civilizations seeking communications in the galaxy, a 2011 study later published in the Proceedings of the National Academy of Sciences suggested that Earth could be a rare bird among planets. A theory written by Princeton University researchers David Spiegel and Edwin Turner said that it took at least 3.5 billion years for intelligent life to evolve, which indicates it takes a lot of time and luck for this to happen. Other explanations for the Fermi Paradox include extraterrestrials spying on Earth, ignoring it altogether, visiting it before civilization arose. There is also another possibility. Maybe we ever detected them, but our governments are hiding the truth for different reasons. Who knows after all? Was this variable taken into account in the calculations? Is the human factor well taken into account in all these equations? I think that if we want to be completely objective on this issue, all variables must be considered. Of course, there is often a gap between theory and reality. I think that there is also still an unexplained part of everything that makes our universe. Because if we could explain everything about it, it would be no secret to us, and of course, we would have already left the Earth and met alien civilizations. Discussion on this topic remains open. Thanks for watching. I'll be back really soon. Open your eyes, watch the sky. Live long and prosper!